All right, lesson 2.7 for geometry. We're going to learn two new properties. This will wrap up our properties lessons here. One of them is called the transitive property, and the other one is called the substitution property. Both fairly logical. I think one will be brand new to you, and one you might have recognized from other things that you have done before. So that's our goal, is to really learn those transitive and substitution properties. All right, so you actually have two warm-ups today. They look kind of similar, but I think you could tackle both of them. If you haven't done it yet, why don't you go ahead and see what you can do. They're both of these drawing conclusions problems, right? You got a little bit different givens, a little bit different pictures going on in each of them. But I think you should be able to draw some interesting conclusions from these ones. So pause your video if you haven't done them yet and see what you can do. All right, so in this first one, we are given that angle A is congruent to angle B. And then we're given that angle A is congruent to angle C. So A is congruent to C. So what could we conclude then? Well, if you're having trouble seeing it, and maybe some of you have already seen it, but if you're having trouble seeing it, let's say that we knew angle A was 23 degrees. Well, if angle A is 23 degrees, then angle B would also have to be 23 degrees, right? But if A is congruent to C, then angle C would also be 23 degrees. So that means that these two have the same measure, right? So angle B would have to be congruent to angle C. Now, I didn't have to give you a number. This could just be X, right? In which case, this would be X. And then this would also be X, right? So you don't actually need an angle measure for that to work, but sometimes it's easier to see it when you put a number in there. So big conclusion you could make from this one, hopefully you saw it, was that angle B would be congruent to angle C. Now we don't really have a theorem for that yet, right? So maybe that's something coming up. Let's look at this other warm-up. So here in the second one, my first given, angle 1, is congruent to angle 2. That was the first one. Second given, angle 3, is congruent to angle 4. Third given, angle 2 is congruent to angle 4, which means this should really have a double mark, just like angle 4 has. But then angle 1 should also have a double mark, right? So I was given 1 was congruent to 2. I was given 3 is congruent to 4. Now that I know 2 is congruent to 4, they link up with these two. That means I also know that 1 is congruent to 4. Oh, excuse me, 1 is congruent. I circled the wrong ones. I was given that 2 is congruent to 4. I apologize. So I also know that angle 1 is congruent to angle 3. The rest of them were all given to each other, right? I guess I also know that angle 2 is congruent to angle 3, etc., right? But if you kind of want to link it all up, to really get to this one, you could see I had angle 1 is congruent to angle 2, and then I had angle 2 is congruent to angle 4, and then I had angle 4 is congruent to angle 3, and so I could say first to last, angle 1 is congruent to angle 3. Now you could have a lot of those combos, but really all the other three were given to you at some point in those givens. Okay. Wait, so that was congruent, and linking up the congruents. So these are examples, actually, of what we call the transitive property. If one thing is congruent to another, which is congruent to another, then the first is congruent to the last. Now, in the first one, this one's a little bit easier to wrap your brain around, right? Both angle B and angle C were congruent to angle A. If two angles are congruent to the same angle, then they're congruent to each other. That's pretty straightforward. The second situation is a little bit harder to comprehend, but hopefully your experience with those complementary and supplementary theorems, your experience with the addition property and the subtraction property are helping you build up to the idea of this last one. And that was, if two angles are congruent to two congruent angles, then they are congruent to each other. So those angle 1 and angle 3 were both congruent to 2 and 4. And so then they're congruent to each other because those two are congruent, right? Angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. Angle 2 and angle 4 are congruent. If two angles are congruent to two congruent angles, then they are congruent to each other. That's the second transitive property. So you've got your two transitive properties here, just like you had two addition properties, you have two subtraction properties. These are your two transitive properties. So the first one, if angles or segments are congruent to the same angle or segment, then they are congruent to each other. And then the second one, if angles or segments are congruent to two congruent angles or segments, then they are congruent to each other. So your two different versions, just like addition, subtraction, complementary, supplementary, all of those theorems all had these two options. So hopefully you're starting to get the hang of it. The confusing part with transitive is all of the words congruent that are in there. It sometimes gets to be a little bit too much, but do your best and keep those straight. So those are the transitive properties when you're linking up different congruent things. Okay. So let's have a proof here. Now, I know it says attempt this proof on your own, and you surely could. I will tell you this one's a little bit tricky, so maybe you just want to watch the video on this one. You are given that angle 1 is complementary to angle 2. Okay? Angle 2 is congruent to angle 3. And our conclusion is that angle 1 must be complementary to angle 3. Let's walk through the steps here. So our first step, number 1, angle 1 complementary to angle 2. Given. So obviously now in our heads we're thinking something about, okay, well, this must be a right angle then, right? And you could write an if-then form if we needed it, although I'm not sure that we do. Okay, so angle 1 and 2 forming a right angle. Step 2, get a color, here we go. Step 2 is that angle 2 is congruent to angle 3, and that was given. So angle 2 and angle 3 have the same measure, right? So if angle 1 and angle 2 add up to 90, 2 and 3 have the same measure, then 1 and 3 must also add up to 90, right? If this is x and this is x, and those two added up to 90, then the 1 and 3 has to add up to 90 as well. So this does make sense. Like logically, we understand. We could swap those two out because they're congruent. The tricky part is, well, how do I say that in the proof? Angle 1 is complementary to angle 3. Well, you kind of, as we walk through that there, we kind of said it, right? We had the wording from up here, angle 1 is complementary to, right? Angle 1 is complementary to. But I can swap out the 2 for the 3 because of this congruent step. So I can flip-flop the 2 and the 3 because I can plug that 3 in for 2 because I know that they're congruent. That idea of plugging it in for, that's called the substitution property. Now, I'm sure you're going to be super excited about this. There is no if-then form for the substitution property. It's really tricky, right? How would you even say that if two things? You can't, right? So we don't have an if-then form. So here's one of the very few exceptions to our if-then form policy. However, when you write down just write substitution property, but then you need to put in parentheses the steps you use to substitute. So I used steps 1 and 2 in this case, right? I needed my wording from step 1. I needed the step 2 where they were congruent to know that I could swap them out. So substitution property, and I used steps 1 and 2 for the wording and for the congruent parts. So you got to use those parentheses. Now your answer key is not going to include those parentheses because they might do it in a different order than you might, and it just kind of takes up a little bit too much room. So they don't ever include those, but I would really like you to include those so that it's your double check. Hey, do you have the step that you're getting the wording from? And do you have that congruent step that you need in order to swap those numbers out? So it's kind of your safeguard. All of your if-then forms have the safeguard built in. Your if part of your if-then is your safeguard. If you're saying it in an if, it has to be written in a statement before that. So this is your safeguard for this one because there is no if-then form. All right, so we did it. We got our new theorems. We got our transitive properties, the first and the second one there, same angle or two congruent angles, and now we've got the substitution property. So the trickiest part now is understanding when do you use which one. Okay, so notice for our transitive properties, congruent to congruent to congruent, everything has to be congruent to use the transitive property, and then you have to write an if-then form. Notice here for our substitution property, I had words other than congruent. In my step where I was writing the substitution property, in this step here, I was using those words, I had the words complementary to. This is not a congruent step. This is something other than congruent, and that's when I know it's going to be the substitution property. If the step you're in has a congruent symbol, then it's not substitution, it's transitive. So be careful of that, okay? So the next couple of proofs that we have in our notes are practice for you to make sure that you understand when is it substitution and when is it transitive, and really making sure you got that transitive if-then form down on when to use which one. So here you go. This one I know you can do on your own. Segment FG is congruent to segment KJ. Segment GH is congruent to segment KJ. Prove that segment KG bisects segment FH. Go ahead and pause your video, take a shot at your proof, and then check your answer down below or continue on with the video if you want an explanation. Okay, here we go. So in our given, we have step 1. Segment FG is congruent to segment KJ. Given FG congruent to KJ up there. Okay. Step 2. Segment GH is congruent to segment KJ. That's also given. Now I already have KJ marked with one line, so I'm going to put another one line down here on GH. So now I'm trying to prove that KG bisects segment FG and GH. Well, in order to know that that's bisecting FH, I would have to know that FH is split into two congruent parts, right? Well, it looks like I just showed it. My picture already shows it. I just need the reason here. So FG is congruent to GH. Now, is this substitution or is this transitive? Hopefully this one jumps out at you. Notice step 1, congruent. Step 2, congruent. Step 3 that I'm in right now, where I'm trying to write my reason, is a congruent step. Since this step is a congruent step, this has to be the transitive property. If two segments are congruent to, now, are they congruent to two congruent segments, or are they congruent to the same segment? Take a look. It is, in fact, both congruent to KJ. They are both congruent to the same segment. There are only 3 segments that I'm talking about here, right? Total. So this is if two segments are congruent to the same segment, then they are congruent to each other. So this was the first transitive property, the transitive property number 1. That first one that we listed is what this reason should be. The first transitive property, not substitution. If you wrote substitution there, you're wrong. Erase it. Go back and write the transitive property. Okay, but now that I know segment FG is congruent to segment GH, I'm not finished, right? That wasn't done. I'm trying to prove that KG bisects segment FH. So I have one more step that I have to include. Step 4, my proof statement. Segment KG bisects segment FH. And my reason, now remember, your if part is what has come before. If a segment is split into two congruent segments. So the two congruent segments is what came before this one, right? Then the segment is bisected. The bisect part is what I'm saying in this step. So that's the then part of the if and the then. So if is what came before, the two congruent parts. Then is what I'm saying right now, that it is being bisected. All right, so there's that proof. Hopefully that one went okay with you. Again, that was transitive property, not substitution. And there are two segments that were congruent to the same segment. All right, let's check out the next one here. All right, next proof, angle 1 is congruent to angle 2. Your job is to prove that angle 1 is supplementary to angle 3. Go ahead and pause your video and check this one out. Okay, my one and only given here is that angle 1 is congruent to angle 2. Given. Okay, I'm trying to get that angle 1 is supplementary to angle 3. Oh boy. Well, I see that angle 2 and angle 3 are supplementary, right? Angle 2 and angle 3 are supplementary. If I do a different color here for this, those are adding up to that straight angle. Okay, so maybe I want to start there. So step 2. Before I can say supplementary, though, I have to have a straight angle, and my straight angle has to have a vertex right here. So I better say angle X, Y, Z is a straight angle. And this is assumed from diagram. All right, so now I have my straight angle. So now I can say that they're supplementary. Angle 2 is supplementary to angle 3. If two angles form a straight angle, then they are supplementary. Okay, notice if they form a straight angle, that's the if part is the step that came before it, then they are supplementary. That's what I'm saying in this step. So just again, double checking you got your if and your then in the right order. And making sure that you included that assumed from diagram step because it is in our if part of our if then. All right, so I have that angle 2 is supplementary to angle 3. Right? I have angle 2 supplementary to angle 3. Okay. And I know that angle 1 and angle 2 are congruent. So then I should, if I'm trying to get to angle 1 is supplementary to angle 3, I should be able to just swap out 1 with 2. So step 4, oops, sorry, there we go. Step 4, angle 1 is supplementary to angle 3. Now notice the step that I'm writing right now where I'm trying to figure out my if then or my reason, right? This is not a congruent step. This step that I'm figuring out right now is supplementary to, right? This is not a congruent step, so this is not going to be transitive. This is substitution. So substitution property, and remember when I use substitution property, I want to write in parentheses the steps that I used. So here I got my wording from step 3, and I've got my congruent step to know that I can swap those numbers out however I want was step 1. So I have steps 1 and step 3 in parentheses. It doesn't matter what order you write those numbers, 3, 1, 1, 3, doesn't matter. But those are your if and your then, right? Wording from one of them, swapping out with that congruent step from the other one. So this one was substitution, but don't forget to write your numbers in parentheses on what steps you used. All right, I hope that those last couple of proofs really cleared up when is it transitive, when is it substitution. Honestly, that's the trickiest part of this lesson. And then really figuring out how to remember the wording for that transitive property. So hopefully that helped you kind of clear that up a little bit. But that's it for the lesson for today. So just remember, transitive property is all congruent, but be careful, are they congruent to the same angle or segment or two congruent angles or segments? And then the substitution property, that step you're writing for that step right there, has to be something other than congruent. If you have words that are not the congruent symbol, that in that single step, then it has to be the substitution property. All right, so you have some homework from 2.7, a few problems that are going to help you really nail down and understand if you know when is it substitution, when is it transitive. If you're getting stuck, you seem to always be getting those ones wrong, take a couple of those additional practice problems, check them out, ask your teachers, but hopefully you'll get them pretty quickly.